Hello, math virtuosos. Here we are, another installment of mathematics with Mr. Sivadas, and we're going to continue working with inverse trig functions, but now we're going to put numbers in them, and we could just throw that in a calculator, take the inverse tangent of 4/3, and that would give us an angle, and then take the cosine of that, and that would give us our approximate answer. But it would be approximate. We can find the exact answers without a calculator. If you check it with a calculator, it's interesting. You don't have to have it in either radian or degree mode. You'll get the same answer either way. So let's take a look at this. So how are we going to get this exact answer? So what we do is we draw a triangle, and it doesn't have to represent the actual shape of the triangle at all. We're just using this as representative. And if this is our angle theta, well, the tangent is the opposite. This is our opposite. And this is our adjacent over the adjacent. So that means this is 4 and this is 3. All right. So to get the cosine, we're going to need the hypotenuse and the adjacent. So I made a nice easy triangle here. This side here is just the square root of 3 squared plus 4 squared. This is the hypotenuse, so it's going to be the sum of these two squared, the square root of that, which is square root of 9 plus 16, which is the square root of 25. So this is 5. So now, the inverse tangent gave us our triangle. Now, from that, we look at the cosine, and the cosine is equal to 3 over 5. The cosine is this one over this. Okay, let's try this one. Again, just draw a triangle. It doesn't matter how close it is to the actual angle. It's just a representation. Now we have the sine. Now the sine is the opposite, which is right here, opposite the angle, over the hypotenuse. So the hypotenuse is 6 in this case. So this has to be, now this is the difference. This is the shorter side. So this is the square root of 6 squared minus 5 squared, which is the square root of 36 minus 25, which is the square root of 11. So that's this length. Now, we want the tangent. The tangent is the opposite over the adjacent. So the answer is 5 over the square root of 11. And if we want to rationalize that, we could say 5 square root of 11 over 11. But this is an all right answer here. Okay, let's do one more. Okay, again, I don't care how accurate my triangle is, because my triangle is just so I can get the concept of what I'm doing. The cosine, okay, the cosine is the adjacent. This is adjacent to the angle over the hypotenuse. So there's my cosine of theta. So now I just need this other side, and this will be, since this is one of the shorter sides, it's 7 squared minus 4 squared. So it's the square root of 49 minus 16, which is the square root of 33. Okay, so now we've got all three sides, and now we want the sine, which is the opposite or the hypotenuse. So the sine is equal the opposite, which is a square root of 33 over the hypotenuse. Okay, so, and we can check these to make sure they're right, but let's try another type. Here we have x's here. We can't check these with a calculator. We can't put these in a calculator, but we can do the same thing we did before. So I make a triangle. Here's my theta. So let's put, what do we have? We have the tangent, inverse tangent of x. The tangent is the opposite over the adjacent. So that means this must be an x if this is a 1. So here, then the inverse tangent, the tangent is just x over 1. So now this one here must be the square root of 1 squared plus x squared. Okay? These two squares add together, take the square root. We don't need the square on the 2. We can remove that. And now we want the sign. The sign is just the opposite over the hypotenuse. So the sign is equal x over the square root of 1 plus x squared. Okay, let's try this one. I want to try a lot of these different ones so we can get an idea. Here, the sine of x, the inverse sine of x. So the sine is the opposite over the hypotenuse. So that means this must be x, and this must be 1, because this over this makes x. So this one would have to be, the large side is 1 squared, which is 1, minus x squared, and the square root of that. Okay, here's our sine. And let's see the side. We want the cosine, and the cosine is this one over this one. So this is just going to be 1 minus x squared, square root of that, because this one over this one. And lastly, let's look at this one. So we've got the cosine of x. So the cosine is the opposite over adjacent. Did we do that before? I guess not. Opposite. I don't mean opposite over adjacent. Adjacent over the hypotenuse. So these are all different. It's kind of nice. That's why I want to do tangent, sine, and cosine, inverse. They're all different here. So this one will be 1 squared, which is 1, minus x squared. That's our other side. Now the tangent is the opposite over the adjacent, but the cotangent is 1 over that. So the cotangent is going to be x over 1 minus x squared. Okay, so again, here's our cosine, x over 1, which is x. Other side, the tangent is just this over this, but the cotangent is reversed, so it's x over that. Okay, we'll see you in the next video.